Yeah, in the last class, we have completed backtracking, correct? What are the topics we have discussed under backtracking? N-queens, Hamiltonian circuit, subset problem, and graph coloring, right? Yes or no, students?
Yes, sir.
Yeah. So in today's topic, we're going to discuss about branch and bound technique. Okay. So what is this branch and bound technique? Okay. Now in backtracking, we have solved the problems to find the feasible solution, isn't it? For example, Hamiltonian circuit, we have solved to find the path, round trip path. And in subset problem, we have to find the subset such a way that the sum is equals to B. And n queens, we are placing the queens in the proper places such a way that it follows the constraints, isn't it? Yes or no, students? Hello?
Yes.
Yeah. Correct. So now in backtracking, we have solved the problems to find the feasible solution. So what do you mean by feasible solution? From the third module, we are discussing this. What do you mean by feasible solution? The solution which follows the constraints, which follows the given constraints, then that solution is known as what? The feasible solution. But in branch and bound technique, we are going for optimal problems or optimization problems where we are finding the optimal solution. For example, in Hamiltonian circuit, we are finding the round trip path. But among the Hamiltonian circuit, the shortest path will be what? Will be traveling salesman problem. Yes or no, students?
Yes, sir.
Isn't it? So Hamiltonian will be the feasible solution. Correct. Among the feasible solution, which is the best solution, that will be what? That will be the optimal solution. To find the optimal solution, we are going for one technique, that is branch and bound technique. Okay. So branch and bound is applicable only to optimization problems where we are computing the solution based on the objective functions. So for each problem, we'll be having some objectives. For example, if you take an example of TSP, what is an objective of TSP? We have to visit all the cities. What? We have to visit all the cities only once, correct?
And come back to the source.
And come back to the source city. From the last city, we need to come back to the source city. Okay. Now, here we'll be using some terminologies like upper bound and lower bound. Now, since it is optimization problem, we'll be finding the some problems will be maximization problems, some problems will be minimization problems. For example, TSP. TSP, are we finding the maximum cost or min cost? Are we finding the maximum cost or minimum cost in the TSP problem? Minimum cost. Then the TSP problem will be a minimization problem?
Yes, sir.
So that time we have to find the lower bound. In the problem, we have to use lower bound. Whereas knapsack problem, we have to get what? Maximum profit within the given sack. We need to put the items in a sack such a way that we get what? Maximum profit. The knapsack will become what type of problem? Maximization problem. So we'll be using, for that problem, we'll be using upper bound. We'll be using one terminology called upper bound. So have you understood what you mean by maximization problem and minimization problem? Yes. So in this topic, branch and bound, we have three types, three different problems. One is assignment problem, knapsack problem, and TSP problem. So in today's class, we're going to discuss about assignment problem. Okay. So have you understood what you mean by feasible solution and what you mean by optimal solution?
Yes, sir.
What do you mean by feasible solution?
Find a constraint.
Yeah, that satisfies the constraint. That satisfies all the problem constraint. Then that solution is known as feasible solution. Among feasible solution, which is the best solution, it might be, it depends on the problem. Some problem requires minimum value, some problems requires what? Maximum value. So if it is the best solution among that feasible solution, which is the best value, that will be the optimal solution. For that example, you can take Hamiltonian circuit. Finding the Hamiltonian circuit is a feasible solution. Among that, shortest Hamiltonian circuit will be what? Will be the optimal solution. That will be TSP. Understood, right? Yes. Now, in backtracking, we have constructed the state space tree, isn't it? We have constructed the state space tree by following what method? Depth first search method, isn't it? We followed depth first search manner to construct the tree, isn't it? Whereas in branch and bound, we will use breadth first search, BFS. We'll use BFS. So now we'll just see a difference between the backtracking and branch and bound. So as I said, backtracking is applicable for finding the feasible solutions. Whereas branch and bound is applicable for finding what? Optimal solutions, correct? So among the feasible solution, which is the best, we need to find out, that is by using branch and bound technique. And we know that in branch and bound, in backtracking, we have constructed the state space tree using DFS. Whereas in branch and bound, we will use breadth first search to construct the state space tree. Any doubts still here? No, right? Okay. So I'll come to this terminating conditions later. After discussing the problem, I'll come for this slide later. Okay. So now we'll go to the first problem. It's very, very important problem. Assignment problem. Okay. The objective of the assignment problem says like this. We have n persons. Now here you can see that person A, person B, person C, person D, we have 4 persons and we have 4 jobs. We have 4 persons and we have how many jobs? 4 jobs. So we need to assign the jobs to a person. We need to assign our jobs to a person such a way that the total sum will be the minimum. The total sum will be what? Minimum. Okay. So now you tell me, is the assignment problem is a maximization problem or minimization problem? Minimization problem, because we need to assign our jobs to each person such a way that we get the smallest sum. When you add all the jobs, you have to get the smallest sum. And what is the constraint here is, if you assign a job 1 to A, I should not assign the same job to other person. So what's the constraint? If I assign one job to a person, the same job should not be assigned to other persons. So I'll just read out the constraint here. Select one element in each row of the matrix so that no 2 selected elements are in the same column. In the sense, the columns represents here the jobs and rows represents the person. Person A, person B, person C, person D. Okay. So if I assign the J1 to person A, I should not assign the J1 to person B, person C, and as well as person D. Okay. Have you understood what is the objective of a assignment problem as well as the constraint? Understood, right? What we should do? So we need to assign the jobs to what? N persons. We have N jobs and we have N persons. We need to assign each job to each person such a way that when I add the sum of the jobs, we need to get the smallest value. Isn't it? Yes, students. So what's the constraint? What's the constraint here? So in simple way, I'll just tell, we need to assign one job to one person itself. The same job cannot be assigned to two or more persons. Same job cannot be assigned to two or more persons. Okay, fine. So now I'll come back to this slide. So first I'll just we'll just go to the Excel and we'll solve this problem. So I'll take this problem here. Since it is a minimization problem, so we have to use lower bound. Okay. Now here, we have to start the problem like this. You forget about the constraint, whatever the constraint is set. First you see in each row what are the minimum values here. You forget about the constraint.
1, sir.
In each row, in this which is the minimum? In A row, what is the minimum? 2. In this B?
3, sir. 3.
In C?
1.
1. In D? 4. That will be the lower bound for the starting state. What is the first step is, without the constraint, find the minimum value in each row. Find the minimum value in the each row. So in 8th row, in the first row, what is the minimum value? 2. In B? 3. In C? 1. And in D, what's the minimum value? 4. So that will be the lower bound for the start state. Shall I write here 2 plus what? 2 plus
3 plus
3 plus
1 plus 4.
1 plus
4.
sorry 1 plus
4.
yeah 1 plus 4. Okay, so how much you get the value? What's the value you get? 10. Get the value as what? 10. Isn't it? Okay. So now we'll go to the problem. Since it is breadth first search, we have to go like this manner. Okay. So now in the first state, what I'll do here is, I will assign the first job to the A. I'll assign the first job to whom? A. Okay. So when I assign first job to A, I will assign the first job. So A arrowhead 1 means I'm assigning the first job. So when assigning the first job, I should not assign the same job to what?
B, C, and D.
B, C, and D. This column is fixed. This column is what now? Fixed. Right? So now what I should, for B, now as usual what you do, from J2, J3, J4, you find the minimum value. For B, what's the minimum value? 3. For C, what's the minimum value? 1. For D, what's the minimum value? 4. Have you understood this, students? Since this column is fixed, now you find out in the remaining columns, find the minimum values for B, C, and D. Yes? For B, what's the minimum?
For A only, we should take the first column, sir.
As of now, first we are taking the first column, next we'll take second column, and third and fourth. First I'm taking the first column. So if I assign
minimum value to A, no, sir, like 2.
We are doing, since we need to assign the minimum value, we'll come to know which is the minimum value among that. So first step, I'll assign the job 1 to A. Next I'll assign job 2, 3 and 4. Among that, which is the minimum we will take. Okay. So in this, I will assign. So if I assign the first job to A person, what are the remaining values for B, C and D? This column is fixed now. You tell. For B, what's the value? 3. For C, what's the value? 1. For D, what's the value? 4. Isn't it? Shall I write here 9 plus what? 2 plus 3 plus 4?
3 plus 1 plus 4.
Yeah, one second, I'll just see here. 3 plus 1 plus 4, correct? 3 plus 1 plus 4 is equal to what's the value?
17.
is equals to how much?
17, sir.
17. Good. It is 17. Next, see now, it is breadth first search manner. I will assign now A to what? A, I'll assign what? The second job. I'm assigning what? The second job to A. Now, if I assign the second job to A, the second column is fixed. The second column is fixed now. Now, you tell me what is the values for lower bound is equal to. Tell me the values. Now, I'm assigning the second job to A. What do you get here? 2 plus 2 plus 3 plus
1 plus 4.
Very good. 2 plus 3 plus 1 plus
4.
1 plus 4. What's the value you get?
10.
Is it 10 again?
Yes.
Yes. Suppose if I assign a third job to A, I'll assign what? The third job to A. Now what you get? When I assign the third job to A, now it's very important. The third column is fixed. Third column is fixed. So I should not assign the same job to other person. So what you get here?
7 plus
Yeah, 1 second. Yeah, 7 plus
7.
7 plus. Now you see the third column is fixed. Now you tell me, leaving this third column, if you want, I'll just fill it. Leaving this third column, you tell me which is minimum for B.
4.
4?
Yes, sir.
Yes, sir.
Isn't it 4? Yeah.
Yes, sir.
1 second.
4, 5, 6.
4. Leaving this third column, what is minimum for C?
5.
5. Okay. What is the minimum for D?
4, sir.
Yeah. What's the value you get? What's the value you get when you add this? Is it 20? 20. Yes. Okay. Right. Next. 1 second. I'll remove this fillings. Okay. Next, now the fourth column is fixed. Now I'm assigning the fourth job to the A person. The fourth is fixed. So now A arrowhead 4. Okay. So lower bound is equal to. Now can you tell me the value, students?
8 plus
8 plus.
3 plus
Very good. 3
1
plus.
plus 1 plus
1 plus 6. Correct. Because the fourth column is what? Fourth job is fixed.
6.
What is the minimum value among this?
18.
Sorry, when you add this, what's the value you get? 18. You get what? 18. Now you see, among these 4 values, which is minimum?
10 is minimum.
10 is minimum means which job I should assign to A?
Second.
Second job I should assign to A? Yes?
Yes.
Yes. So after this, the first level, we came to know that we need to assign the second job to A. We have to assign what? The second job to A. So in BFS, we'll be constructing partial solutions. In each level, we'll be constructing the partial solutions. Okay. So what is the partial solution we got here as of now? We need to assign what? The second job to A. We need to assign what? The second job to A. Then, since this node is the best among all the other nodes, so we'll be telling this node as a promising node. We'll be telling this node as what node? Promising node, and other nodes are reject. We need to reject. We need to reject the other nodes. These are the nodes are we terminated here itself, because among this, which is the best here?
10.
The second node was the best. So these are known as non-promising nodes. We need to reject. We need to terminate. Okay, understood, right? So now, which job we have assigned for A?
Second job.
Second job. Now the second job is completely blocked. It's blocked, correct? It's blocked, and since second job is completely blocked, I'll block this column. So now in the next iteration, we need to assign the job for B. Now, which are the jobs can be assigned to B now? Either J1 or J3 or J4. Okay, so we'll do the same process here. Any doubts still here, students?
Yes, sir.
No, right?
Yes, sir.
Okay, shall I go for the next iteration?
Yes, sir.
Yeah. Now we can assign for B. What are the jobs we can assign? Either 1
3.
or what?
3.
3. We cannot assign 2 now, isn't it? 2 is already fixed. Now we can assign what? Either 1, 3, 4. Okay. Yes. Now lower bound is equal to the A job is already fixed, right?
Yes, sir.
2 plus. Shall I use the same value for all the values? So lower bound is equal to 2 plus, because A value is already fixed, right? So lower bound is equals to 2 plus is fixed for all these 3 things. Now come for this here. So if I assign the first job for A, first job for B, what are the remaining values, minimum values for C and D?
1 and 4.
1 and 4?
Yes, sir.
Yes? Yeah. Now what you get here? 2 plus what? 6 plus
1 plus 4.
1 plus 4 is equal to how much?
13.
Yeah, is equals to 13. Any doubts still here? No, right? Yeah. Next I will assign third job to B. I'll assign third job to B. When I assign third job to B, C will take what value now?
5.
5. B will take what value now?
4.
4, isn't it? When I fix the third job for B, C will take 5 and B will take 4, because the same column I should not assign the jobs. When job is assigned for one person, the same column we should not keep. Okay. Now here 2 plus what do you get? 3 plus
5 plus 4.
5 plus 4.
3 plus 5 plus 5 plus what? 4. What's the value you get?
14.
You get
14.
You get 4. Okay, fine. Next. 1 second. Next, now fourth job I'll assign to B. When I assign fourth job to B, yeah. Now you tell me C will take what value and D will take what value?
C will take 1, sir.
C will take, yeah, very good. C will take what? 1. 7 plus 1 plus D will take what value?
7.
D will take what value?
7.
7. Because that column is what? Fixed. I cannot assign the same value. Isn't it?
Yes, sir.
So what's the value you get now?
17.
17. Yes. Any doubts to here? Okay. So among this, which is minimum?
13.
13 is minimum, right? So now I should take this node. So from this we came to know that we need to assign the job 1 to B.
Yes, sir.
So these two nodes are known as what nodes? B equal to 3 and B equal to 4.
Rejected.
Reject. Non-promising nodes we need to reject. So are you able to find the difference between BFS and DFS, like backtracking and branch inbound? In backtracking we are finding we'll go depth first search and then we'll come to know that this is not a solution. We need to backtrack. Whereas here at every level we are able to find out which is the promising node, which is non-promising nodes, and we are rejecting it. Yes, students? Yeah. Yeah, from this we came to know that which job should be assigned to B. Which job should be assigned to B? See here, which job? One. Job 1, isn't it? So, is job 1 is blocked now? So, job 1 is blocked. So, in this, I have assigned J1 to B. Any doubts still here? Okay. So now, what are the options available for C now?
3 and 4.
3 and 4, correct? So now here, now I can assign C, the third job I can assign to C, or I can assign what? The fourth job to C. Fourth job to what? C. Now, since the first value on the A job and B job is already assigned, so I'll use the same value. 2 plus what? 6. 2 plus 6 is already fixed. Plus. Now, tell me what values we can assign for C now. If I assign J3 to C, what value? 1. What will be the value for 4? Sorry, D.
4.
4. For D, it will be 4. For D, it will be 4. So here, so 2 plus 6 plus 1 plus 4. What you get the value as?
13.
13. Next here. Now lower bound is equals to 2 plus 6 is already fixed for A and B job. Now suppose if I assign the fourth job to C. Fourth job if I assign to C. 8 if I assign, D will take what value now? Now this column is fixed now. This column is fixed now. Now I'm assigning 8 fourth job to C. Then obviously should take which value now?
9.
9, because this is blocked. This is assigned already, correct? Yes. Now here, what I get? 8 plus 9. What's the value you get?
25.
25. Among this, which is minimum?
13.
13. So from this we came to know that we need to assign the third job to whom?
C.
C, isn't it? Yeah. So now what I should do? I should lock the
Third job.
third job, and third job is assigned to C. Third job is assigned to C. Yes. So what is left out now? Obviously we should assign which job now?
D.
Fourth job.
Fourth job to whom?
D.
D.
That's all. Only one option we have available here. We need to assign the fourth job to D. Now we get lower bound as what? Lower bound as 2 plus 6 plus 3 is already fixed. 6 plus 1. The third job is already fixed for third C. 14. What is left out value?
4.
4. Only 4. Only 4 here. So plus 4 is equals to what?
13.
13.
That's all. So when there is no point, when you reach end, we need to terminate. So now you tell me, in which are the cases we have terminated here? The first, for this nodes, we have terminated here itself because we need not continue further because this is not the best. It was non-promising also, we have terminated. And when we reach end, further we cannot go, also we have terminated. Correct? So what's the solution for this? What's the solution? What is the solution? What is the solution? So I'll just do a short recap here. First we have started with assigning 2 plus 3 plus 1 plus 4. Without following the constraint, we have simply found the what? Minimum values from each rows. We have found what? The minimum values from the each rows. Any doubts still here? No, right? Next we have assigned what? The first job to A person. So if I assign the first job to A person, so this column I should fix, the remaining values we should write. So shall I go fast in this slide? You have understood that Excel sheet?
Yes, sir.
The same thing I have represented here. We'll go in this manner. When you are solving also, we have to go like this. We have to draw like this. Among this, which is minimum?
10.
10. So now you have to branch. Now here, in this node, you have to start the branching. All this, we need to stop the branching because it is non-promising nodes. Now see here, in this node only I am branching. I will assign B to 1, 3, third job as well as fourth job. Among this, which is minimum?
13.
13. So I will branch here. This 2 is non-promising nodes. I will reject. Okay, fine. So I'll assign C to 3 as well as 4. Among this, which is promising node here?
3.
3. Here I will assign D equal to 4. Now solution is, second job is assigned to person A, the first job is assigned to person B, and third job is assigned to person C, and fourth job is assigned to person D. Is it easy? Have you understood this?
Yes, sir.
Okay. So now, as I said, we'll see when we need to terminate in the branch and bound, when we need to terminate. Okay. So now, if any one condition satisfies, we need to terminate. Further, we should not proceed with that node. As already we have seen, the first point you see here, the value of the nodes bound is not better than the value of the best solution seen so far. See, among A equal to 1, 2, 3, 4, which was the best?
A is equal to 2.
A equal to 2, correct. Other things we have rejected, no?
Yes, sir.
That was not better. Yeah. So this is one terminating condition. You have understood, right? Then the next point is the node represents no feasible solution. Suppose if that node is not following the constraint, also we need to reject that node. Okay. We need to reject that node if that node is not following the constraint. This you will understand in the knapsack thoroughly, this point. In the knapsack, suppose if that item is not fitting into the sack, what we will do? If that item is not able to fit into the sack, what we will do? We will reject.
Yes, sir.
We will reject. Suppose in TSP, from the last city, if you don't have a edge, direct edge to reach the source city, what we will do? We will reject. Correct? Yeah. When it is not following the constraint, we will reject. That's the second point. The third point, now when you found the solution, did we stop? Here in this, when we reach D, can you go further? Do you have any other values to go further? No, right? Once we reach end point, we need to terminate, correct? Yes. Now see here, the subset of a feasible solution represented by the node consists of a single point, means that's the end point. Further, we cannot continue. That time also we need to terminate. Understood this? Okay. So now we'll solve one more problem similar to this. Yeah. Is this visible? This value is visible? Yeah. What's the first step we should do here? First, in the start, first we find in each row what is the minimum value. Correct? In each row we should find the minimum value. So in A, what is the minimum value?
3.
In B?
2.
In C?
1.
1. In D, what? 3. That will be your first node.
Yes.
3 plus 2 plus 3, 1 plus 3 is equals to 9. Next, if I assign the first job to A, means if I'm assigning the first job to A, what is the value it will take? A value will take what? 10. Now, leaving this first column, tell me the values for B, C and D.
2
plus 1 plus 3. Is it correct? 10 plus 2 plus 1 plus 3 is equals to 60. Suppose if I assign the second job to A. Now see here, I'm assigning the second job to A. This column is fixed. Tell me the values. 3 plus
3.
4, 1, 3.
4, 1, 3. Very good. 4, 1, 3. 3 plus 4 plus 1 plus 3 is equals to 11. Now, if I assign the third job to A, that is 9. Let's fix this column. 9 plus
2 plus
2 plus
plus 3.
9 plus 2 plus
6 plus 3.
Very good. 6 plus 3. Is it correct? 9 plus 2 plus 6 plus 3, 20. Suppose if I assign the fourth job to A, 12 plus
4 plus
12 plus
4 plus 1
fourth
plus
job. Fourth job I'm assigning for A.
12 plus 4 plus.
Not 4. 2, right?
Yes, sir.
B has 2, right?
12 plus
12
2
plus
plus.
1 plus
5.
1 plus 5. Because the fourth column is fixed. I cannot take 3. I should take what? 5.
Yeah, sir.
12 plus 2 plus 1 plus 5. Understood till here? Yes. Among this, which is the promising node for us? Which is minimum here? 11. Yes. So I'll take 11. So now from this we came to know that second job should be assigned to person A.
8.
So now, so for B, what are the options available? 1. For B, what are the options available? 1, 3, 4. So I'll go for 1. If I assign 1, already the second job is fixed, right? The second job is already fixed for J2. So 3 plus 5 I'll write as it is. 3 plus 5 I'll write as it is. These 2 columns you leave. Now you tell me what are the minimum values for C and D. 1 plus 3?
So 1.
Is it 1 plus 3? Yeah, you get 12. Suppose if I assign the third job to the B person. Suppose if I assign third job to the B person, what are the minimum values for C and D?
6 plus 3.
6 plus 3. Very good. 6 plus 3. 3 plus 4 plus 6 plus 3. Next, if I assign the fourth job for B, if I assign what? The fourth job for B, what are the options available for C and D?
1 plus 5.
No, the second column is fixed. Second column is already fixed. It's blocked
1
for
plus 8.
A.
1 plus 8.
1 plus 8. 1 plus 5.
8.
Fourth job I'm assigning. Sorry. Correct. 1 plus 8. Sorry, I did a mistake. Is 1 plus 8. 1 plus 8. What do you get? What do you get the value as? What do you get the value as? 12 plus 2 plus 14, 15, 23?
23.
Yeah,
sir.
23. Yes. We have solved till here, correct?
Yes, sir.
Yeah, sorry, I changed. I changed there. 1 second. Instead of changing here, I changed here. It is. It was correct, right? 1 plus 5 only, no? Here. It was like 6, 7, 8. It was 20. Here I should change. Sorry. It is 8. You get how much?
23.
10, 18,
21.
22, na? 21. 21. Correct. Yeah, it's correct. Now you tell me. Till here we have discussed, right? Yes. Now, next, among this, which is minimum?
12.
12. So now J1 and J2 is blocked. Students, J1 and J2 is blocked because J2 is blocked to A and J1 is blocked to B. Okay, fine. Now, C has option 3 has or 4. Now 3 plus 5. Now you tell me, if I assign the third job to C, fourth job can be assigned to what? D itself. Correct? So 1 plus 3 you get 12. So what about if I assign the fourth job to C? What's the minimum value you get?
8, sir.
Again you get 8. Yeah. Here it is 8. So what's the value you get? What's the answer you get here? 17, 25?
25, sir.
25. Next. Yeah. So from this we can know that C equal to 3. Which is minimum here?
12.
12 is minimum. So third job is assigned to C. So only one job is left out, that is D. So we'll assign D to, and the fourth job we'll assign to D. We get 12. Okay? The same solution. J2, J1, J3, J4. Okay? Any doubts in assignment problem? Yeah. Okay. So if you have understood, So you have take down this problem and solve based on this. Slide is visible?
So,
Yeah. So any doubts, students? Any doubts? If you have any doubts, you can ask me.
Pushpanathan, Ishan has asked a doubt. Just check in the chat box.
Yeah, ma'am. 1 second.
Yeah. I didn't get his doubt actually.
Ishan,
Yeah.
A equal to 2 notes, sir. 3, 4, 1, 3,
3,
1 and 4 are in the same
4
column.
are in same column.
Yeah.
Which problem?
Ishan?
Which problem? No, he's talking.
Previously, no.
Yeah.
Previous problem. Ishan, are you here?
Ishan? He's
Yeah,
there.
okay, yeah. Ishan, see, as I said, we need to follow the constraint, but a partial way. When you are assigning for a first job, for example, P, if I assign the first job, so only that column is fixed. Other columns you can assign. At the end, we are following the complete constraint. Are you following, Ishan? Ishan?
Yeah, he has replied.
Okay. So only in that particular iteration, that column is fixed. In the remaining columns, you can take the minimum values. At the end, we are following the complete constraint. The end of the solution, we are getting the complete constraint. Nikita
has asked some doubt.
Yeah, Nikita, what if the sum of 2 nodes is the same? If 2 nodes are same, you traverse both, no problem. 2 promising nodes, you traverse both the nodes. Continue with both the nodes. Nikita? Okay, did you get it? Okay. Sindhu, what's your doubt?
Sir, it was by mistake, sir.
Okay, no problem.